version. And now let's look at the 8 megahertz version, which is here. And you'll notice some striking similarities between the two. They both have peaks right out here in this 32,000 range.
Yeah.
Well, the question is what happens if we add those two together? I'm going to load a new file, and I'm going to load the 5 megahertz one on top of the 8 megahertz one.
Right.
And what we see is that the peak now is up around 85, whereas the noise is still down in the range of 25. So this signal has been the signal to noise ratio has improved dramatically here, and this signal is really starting to stick out when you add those two signals together. As is this thing down here at 0, and I don't know what that is. It's not there on all of them. Sometimes it's there, sometimes it's not.
Well, I see this. There's this. What you see is a lot of data at the 0. 0 changes a lot. That's really true. And in the early registers, then it goes along. What my question is, I guess I have two. Is addition? What happened? Wouldn't subtraction show? Because if it's okay, let's say. I mean, okay, the skeptic is going to say, well, you have an artifact in the chip at 3300, and you're just amplifying it.
And he might be correct. But what happens is these other things here.
So wouldn't subtraction be? Wouldn't subtraction answer that? Because
what would happen with subtraction is that it would pull the signal into the noise as opposed to highlighting the visible difference.
Okay.
And while we don't know whether this is an artifact or whether it's some intention that was stored in there, we don't know where these come from.
Okay.
And all we're trying to do with this particular instrument, this gizmo is essentially a spectrum analyzer designed to look at the spectrum of ones and zeros in a memory chip. And so this is just a piece of electronic equipment that is used to correlate and analyze the data that exists. We don't know what caused this peak with this equipment. The equipment can't tell that. All this equipment can tell is there is some signal there that when you take 2 or 3 different chips that were in a similar environment and you add the data together, the signal gets bigger, which says it's signal, but the stuff that's noise does not get bigger. That's the real trick, is when you add stuff together, the noise does not add.
Oh, okay.
It did not get twice as big. It stayed the same size.
Okay. I missed that point. I'm sorry.
Yeah, and that's the real secret, is the noise. When you begin adding signals that are similar, the signal increases.
Very clever.
Yes, and that's why we put this additive function in here. So, say you've got 3 boxes sitting in the same room with the Dalai Lama, okay? And he comes in and he focuses his energy in there, and you pick up readings from all 3 of these devices. What you can do is you can add them together to identify what the signal is versus what was kind of like background noise.
Wow. Yeah. That's incredible. That's incredible. Can I ask for one tweak?
Yes.
which would be as long as you could you load them like up to like maybe 7 or 8, each give them a individual color without adding them.
Unfortunately, because of the way the arithmetic works, they don't actually appear as separate entities in there. And that would defeat the purpose of adding them together if you tried to identify the separate lines.
Oh.
And it would also require a structural overhaul of the way the analyzer works.
Okay. Okay.
That would turn this into a multi-channel analyzer as opposed to a single-channel analyzer,
Okay.
which is not out of the realm of question.
Okay.
If it became something that were important to do, it's just a reasonably expensive kind of a modification.
Yeah, I could see. Okay.
And
Well, it's just if I I'm not. I'm just the first person to ask. So anyway.
let me tell you what I think is probably going to. If I were a critic, I would say, okay, I can see that this thing is showing signals. We don't know where the signals come from, whether they're artifacts and chips, or whether there's some from the fluorescent lights in the ceiling,
Yeah.
or whether it's cosmic radiation, or whether it's somebody's intention being stored there.
That's okay. We at least had validated the sensor technology, and in this first round, we're lacking documentation of the source. The second round of chips, we're not going to be lacking documentation at all, and we'll get smarter and we'll be able to display more results. The fact that I'm
Let
sorry.
me tell you how I would address these guys. One of the things that I would do would be to build a cage that would shield this device from all electromagnetic radiation.
Uh-huh.
And initially, we could build a small one that would be maybe contain 1 cubic foot of space inside of it, and be completely surrounded with like a brass or copper shielding.
Yeah, well, we specify the recommended setup. Sure.
Well, but what we do with this is we demonstrate that this box makes all the signals go away, and the only thing that's left is artifacts that are in the chip.
The Faraday cage?
Of a Faraday cage.
Yeah, I'm not sure the Faraday cage will protect it, but go ahead.
I don't know either. But if, as an example, we saw a noticeable difference with the Faraday cage, then we might do our experiments with particular people who have strong intentions. We might do it inside of a Faraday cage. In other words, picture this.
Oh yeah, I have.
Picture putting the Dalai Lama into a Faraday cage with your device,
Dude.
and figuring out all of the intentions of everybody else that might be affecting this, and trying to capture as pure of an energy of his